Okay, welcome to 7.6 part 2. We got some examples. Hopefully you've seen the part 1 video already if you're watching this, and you have some understanding of inverse matrices. So this is a formula. This is on the front of the packet. It is not a formula that I would ever encourage you using to find these. 2 by 2 matrix is a specific formula. Memorizing this, I think you can see the problem in memorizing this, plus finding the inverse of a 2 by 2 matrix is just as easy as could be with Gauss-Jordan elimination. But we're going to do it this once. I guess I would only use this if I was in an environment where I was just dealing with 2 by 2 matrices and finding their inverses, and I probably would use this formula to program it into my calculator, or more likely into an Excel spreadsheet kind of application. But we're going to go ahead and do it. If you like it, be my guest, but this is the last time you'll see me use it. So this says if we have a 2 by 2 matrices, all we have to do is move these A, B, C, D values, the 7, 12, -8, -5, place them appropriately, flip these two around, keep these the same, A, C, and B, but go with opposite signs. I think you can see why memorizing this thing probably not such a really great idea to, unless you're just constantly pounding it in. Okay, so A inverse is 1 on. I need my A value. My A value is the 7. I need my D value. My D value is the -5. I need minus. I need my B value, which is 12, times, I need my C value, which is -8. And then I've got to shuffle around this matrix a little bit. What's going up here is supposed to be my D value, which is -5. What's going over here is supposed to be the opposite of B, which is -12. What's going down here is the opposite of C, the opposite of -8, 8. And what's going down in the bottom corner is A. A is 7. Now, I believe if I was doing this in Gauss-Jordan, I'd probably be done with this just by going through that. And not having, that's without having to worry about memorizing it. So let's see, we get 1 on -35 plus 96 times our matrix. That is 1 on 61 times -5, -12, 8, 7. And that's a perfectly acceptable answer, but you could also, of course, write that as -5 on 61, -12 on 61, 8 on 61, 7 on 61. Most times we would prefer that to be in this form, truthfully. But they each have their place. Okay, let's take a look at 36. And 36 sounds more complicated than it is. In fact, it's quite easy once we get an understanding for it. Find the value of the constant k such that b is the inverse of a. B is a inverse. Well, how do I know that 8 is the inverse of 1/8? Well, if we multiply those, we get 1. So I want to multiply these. And in 2 by 2 matrix land, I need the k value that ensures that I end up with 2 by 2's version of 1, which is the identity 2. This is referred to as I2, the identity 2, identity matrix 2 by 2, is just our 1, 0, 0, 1. Well, if I go through this multiplication process, if I want to involve k, I've got two options here. Spinny finger thing, I can take the -1 times the -1/3 and add to that the 1 times k. And that has to give me 1. Or I could take the 2 times -1/3 plus the 1 times k, and that has to give me 0. I'm just going to do the first one. So spinny finger thing, I get -1 times -1/3, 1/3 plus k equals 1. Oh, k is 2/3. That's it. So not too bad. Okay. number 40. You will actually have a problem like this on the test, and I'm going to divide it into 3 steps, each one 5 points. So you think I'm placing a lot of importance in this problem if it's worth 15 points. However, I will tell you this: I would never use inverse matrices to solve a system of linear equation, to solve a system of linear equations. But there is a place for it when we need to solve multiple, and you'll see that when we get back to problem numbers 57 through 60, how it does have its place, but it's a horrible way to solve a system of equations. Yet you're going to do it for 15 points. And the instructions are going to be really clear. The first 5 points is going to be just to rewrite this as the product of matrices. We've done that. So this is x, no it's not, this is 1, negative 2, 2, negative 3 times xy equals, and I'm going to leave a little space here, and you'll see why a little bit later. Maybe you already know. So that's worth 5 points. It may be the easiest 5 points on the test, but chances are it's going to be 5 or nothing. You know, you're either going to know how to do it or you're not going to know how to do it. And I'm going to refer to this one as A. This is big X, not to be confused with little x. This matrix X, and let's call this one B. The next set of directions is going to say, find the inverse of the coefficient matrix. Well, here's the coefficient matrix right here, the coefficients. 1, negative 2, 2, negative 3. Since it's a 2 by 2, we could do it this way, but I'm not going to. I'm going to go ahead and Gauss-Jordan this. So we have 1, negative 2, 2, negative 3. I attach the identity matrix to it, and we go through the Gauss-Jordan process. That's video 1 goes through this with some explanation, but we'll go through it again here. First hitman 1 needs to be multiplied by negative 2 and go whack this 2. So let's touch them. We get negative, well, hitman row stays the same. Let's start with that. Touch negative 2 and 2, 0. Positive 4 and negative 3, 1. That's about as good a thing as can happen right there. I'd like to get a 1 there. Negative 2 and 0. 0 and 1. And next hired hitman needs to be doubled and go pay a visit to row 1. Touching 0 and 1, 2 and negative 2, negative 4 and 1, negative 3, 2 and 0, 2. 0, 1, negative 2, 1. Now that is a very, very simple problem. We didn't have to do very much, anything like multiply 2 rows, and we ended with 1s here. Once we get down to this position, it's possible we could have a 2 there and a 3 there, and if I did, I'd divide this row by 2 and I'd divide this row by 3. We have to get this. But now we know that A inverse is negative 3, 2, negative 2, 1. That's the second 5 points on this. And then the directions will state, and we're going to practice another one just like this. In fact, like this, only harder. Then the directions will state, use the inverse matrix to solve the equation. Well, just like if I had, let's say 7x equals 35, I could multiply both sides by 1/5 and solve that. Well, here I can multiply this side by A inverse, this side by A inverse. This A inverse cancels A. That's what inverses do. So I end up getting xy equals A inverse negative 3, 2, negative 2, 1 times 1, negative 2. Now, you can see why this is such a horrible way to solve this, because if I just would have Gauss-Jordan this, it would have been easier than adding this stuff on. I have an extra column here, and by the time I got down to here, I'd be done. So terrible way to solve a system. So let's see what we've got here. This is a 2 by 2 times a 2 by 1 our answer is going to end up being a 2 by 1. I think we can just do this one in one step in our heads here. Spinny finger thing, -3 and -4, -7. -2 and -2, -4. X is -7, Y is -4. We'll practice another one, and hopefully I can convince you a little bit later on that there may actually be a place to do this. Now 42. We're gonna set this up the same way, but we're gonna use calculator on this one. I think the author of the book doesn't intend that, but when you get to the 3 by 3, probably 41 in your homework assignment is a 3 by 3. You can go ahead and use calculator on this, but we're still gonna set it up and kind of show the process. So let's go ahead and turn this into matrix multiplication. Coefficient matrix 1, 1, 1, 3, 5, 4, 3, 6, 5 times x, y, z equals -1, 2, 0. I should have left a blank in front of there, but that'll be all right. And if we do the spinny finger thing, we can do a quick check here. I get 1x plus 1y plus 1z equals -1. I believe the rest are going to check out as well. Okay, if this is A, this is big X, and this is B, I should know that x, y, z equals A inverse times -1, 2, 0. Oops, sorry about that. Zoom out here. If I take A inverse on both sides, I get that. Here's the beauty of this. I don't even need to know what A inverse is. I've got A. My calculator can find A inverse behind the scenes. So let's go ahead and grab our calculators and let's enter this 3 by 3 as matrix A, this 3 by 1 as matrix B. So we'll go into edit, 3 by 3. Some of this is, whoops, not a 33. 3 by 3. I like my first row, 1, 1, 1, 3, 5, 4, 3, 6, 5. Give it a double check. Easy to make a mistake here. I think that looks good. Second quit. Second matrix. Let's edit B, which that's already for me set up as a 3 by 1. That's good. 3 by 1, but the values aren't good. -1, 2, and 0. And second quit. So my solution is just A inverse times B. I don't need to find the inverse of A. I just need to enter second matrix A, inverse button, right, shares with matrix, A inverse, and I believe I can just butt matrix B up against it, but I'm going to put times in there. Second matrix B, and we get 1, 7, -9. So the intersection of these three planes is 1, 7, -9. Okay. All right. During this problem, probably be a good time for you to pause and when I give the instructions again on this, to pause it, try it, and see if we match up at the same positions. We got bigger numbers to deal with, but this is really just like problem number 40, and I want to model it after how it's written on the test. So the first 5 points would just be, go ahead and set this up as the product of matrices. I'm going to leave a little blank in here just to try to make sense out of this again. So pretty simple and straightforward after we've done it a few times, but again, it's one of those you either know how to do it or you completely don't know how to do it. Now we're going to find the inverse. In this case, we're going to find A inverse with Gauss-Jordan, unless you're convinced that maybe memorizing this is better since it's a 2x2, but I'm going to Gauss-Jordan this. 18, 12, 30, 24, 1, 0, 0, 1. On the test, the 2x2 you're going to be given won't be as messy as this as far as the numbers go, but might be a little bit more challenging than problem number 40. Might have a fraction. This is actually going to be bad and then get really good really fast. 18 and 30 are not relatively prime, so I don't have to multiply this row by 30 and multiply this row by negative 18, but you could. 18 and 30, they don't match up at 30. Do they match up at 60? Nope, but they do match up at 90. 5 times 18 is 90. So I'm going to multiply first row by 5, and if I get a positive 90 here, I want a negative 90 here, negative 3, and go pay a visit. And as always, Hitman row doesn't change. I get 90 and negative 90, 0. Well, I better get 0, that's why we're doing it. I'm going to write this one off to the side, 60 plus negative 72 for negative 12. Ooh, you couldn't have asked for a better result there. If you look at our moving forward step here, I get 5 and 0, and I get I get 0 and negative 3. Perfect Hitman. Leaving this as it is and sending it up. And I get 0 and 18, negative 12 and 12, 5 and 1, negative 3 and 0. And 0, negative 12, 5, negative 3. And here's what I was just talking about. We can now just divide this by 18, divide this row by negative 12, and we get 1, 0, 6/18, 1/3, negative 3/18, negative 1/6, and 0, 1, negative 5/12, negative 3 on negative 12, positive 1/4. So A inverse is 1/3, negative 1/6, negative 5/12, and 1/4. And if we go back up and take a look at the original, if I'd multiply this by A inverse, these cancel, I would get xy equals A inverse times that. So I just need A inverse times 1323. Probably writing this down more times than I need to. So times 1323. So a little bit of ugly fraction work here, but here's the good news. This is a 2x2 times a 2x1. We're just going to end with a 2x1. But I'm going to give some room because we're going to have some denominator work to do here. Twisty fingers, 13/3 minus 23/6. Not the worst non-common denominators we could have. And negative 5 times 13, negative 65/12 plus 23/4. All right, common denominators. This would be 26/6 minus 23/6. And on 12, negative 65/12. plus times 3 on 3, 69/12. So I end up with 3/6 or a half, 4/12 or a third. And there we have it. So somewhere between 40 and 46 lies the problem that difficulty-wise that you'll be doing. Okay, now this, at home you're not going to be able to, I'd have to put together another video. I'd like to show you how we could utilize Excel at home, but your calculator is still pretty good for this, but it's not a huge sell on why this process might be better in some cases. But I wish, part of me wishes this assignment wasn't 57 through 60. Part of me wishes this was like 57 through 90 or something like that. If there were that many problems on it, you would really buy into this process. So here's the deal on this. I'm going to give you a little bit of investment background here. Consider a person who invests in AAA rated bonds, A rated bonds, and B rated bonds. The average yields are average yields. That means not always. The average yields are 4.5 on the AAA, 5 on the A, and 7 on the B. So the question should be, why aren't we just investing all in B? That's the average yields. B-rated bonds are oftentimes pay more and they're attractive, but they're volatile. AAA rated, if they tell you you're going to get 4%, you're pretty much going to get 4% unless the world's coming to an end. If they tell you it's a B-rated bond at 7%, don't be surprised if 2 months later it's 2.5% or 11%. They can vary based on it's just a more volatile. So anyway, the person invests twice as much in B bonds as in A bonds. Let X, Y, and Z represent the amount in dollars invested in AAA, A, and B. So X plus Y plus Z is our total investment. And we're gonna get a return of 0.045 or 4.5% on X, 5% on Y, and 7% on Z if all goes well. And this equation, I'll let you work this one out if you want to on your own. That comes from the person invests twice as much in bonds B as in bonds A. That comes from that. And here's the scenario I want you to think of on this. You're the investment guru and you got your shop and you have been studying this and you've just decided right now I got about 50 clients that need to come into me and talk about this investment strategy I have where we invest twice in here, and they're going to come in and they're going to say, well, I've got, for instance, $20,000 to invest. Can I get an annual return of $955? That's really what I'm looking for. And we can run the numbers and we can see first if it's possible, and second, if it's possible, how much of it's going into each of these different bonds, and do you want the risk of putting large amounts in this, or do you want the security of investing in the AAAs? So you got to imagine you're going to be doing this repeatedly with this. You're just going to get different investments and annual returns. Okay, let's set this up like we did the previous ones. 1, 1, 1. 0.045, 0.05, 0.07, 0, 2, negative 1 times XYZ is supposed to equal, leave a blank here, is supposed to equal our total investment, which in this case is $20,000, our annual return, which in this case is $955, and the last one is 0. That comes from that little sentence right there. If I call this AX, matrix A, matrix X, and matrix B, it should be clear now that A inverse gives us solution for X if we take A inverse times B. Let's enter these as A and B in our calculators now. A is already in a 3x3, B is already in a 3x1. We just have to edit those. I didn't want that. Three by three. I like the 1, the 1, the 1. 0.045, 0.05, 0.07. Those look good. 0, 2, and -1. Double check them. Second quit, second matrix. Let's edit B. I like the 3 by 1, but I want 20,000. Make sure you got the right number of zeros in there. 955 and 0. And now we can just go to second quit and second matrix. I want to select A. I want its inverse. Use the inverse button. Don't raise it to -1. Bad practice. Matrix X inverse. And multiply that by B. I didn't multiply it by B. Multiply that by B. And we get X is 17,000, Y is 1,000, and Z is 2,000. How would we rate that investment? As risky or safe? Well, we've got 17. The huge majority of our money is in the AAAs at 4.5. That's a pretty safe investment. We could probably make more. So then as the consultant, I might say, are you certain that maybe you don't want to take a look at creating a bigger income? Well, what would we have to do now on our calculator? I'd say, okay, well, let's go back into that matrix B where you were looking for 955. Let's edit matrix B, and let's see, is it possible for us to maybe get $1,050 out of that? We hit enter, we second quit, we just go second entry. Hey, you could do it. You could do it if you want to invest a lot more in here. And you could play around with that. Well, what if somebody said, okay, you know what I'd like to do? I'd like to, let's go to edit. I'd really like to invest $20,000 and get out $7,000 a year. Does that seem reasonable? Probably not. Let's take a look. So second quit, second entry. If you get a negative in here, that's a dead giveaway. It can't be done. Now, that's pretty slick on your calculator. Now, the next person comes in. You would have these entered right now, and I'm telling you, problems 56, 59, and 60 are just like that. All you have to do is change those two values in matrix B and come back to your calculator. So while it's a horrible way to solve a system of equations, it's a great way to solve many systems of equations if the coefficient matrix doesn't change. And it's even better in Excel. If you attend my class, you're going to get an opportunity to see this in Excel. But trust me on that one. It does have its place. It just is really horrible for this. Let me help you. Let me know if I can help you as always, and stay tuned.